So this is an overview of the lab that I promised. First of all, I'm going to check the data with you. We know that chlorine, this box for chlorine was mixed with NaF. It was clear when you were finished, or you might have said green. Okay, so clear, or you might have said light green. Bromine, you probably said yellow. With the bromine mixed with the NaF, you might have said orange, but I'm just going to leave it as yellow. You probably found this to be yellow also. And over here, the iodine, in all three cases, you probably said it was pink. Pink is a variation on purple. Yellow is a variation on orange. So you can see that if it was yellow, that meant there's bromine in that top layer that you're looking at. If it was pink, there was iodine in the top layer that you're looking at. Okay. Then chlorine and NaBr, when that happened, there was a color change. That went yellow. And then for both of these on the bottom, it turned pink. Now notice these pinks, you started with pink and you end with pink. But over here, you started with green, or light looked clear probably to you, but it was almost colorless. And then this is turning pink, so that was a definite change. Same thing here. Bromine was kind of that yellow color when you started, and when you put it with the NaI, the top layer turned pink. Okay. So those are the changes. Now we're going to write down the pairs of chemicals that reacted with each other. They only react if there's a color change. So that means that the only three that reacted were these three. Okay, so we would have NaBr and Cl2. That'd be the first column. And we had NaI and Cl2 and NaI and Br2. Those are the reactions. Now there are 6 pairs that didn't react. And here they are. 1, 2, 3, 4, 5, 6. So you just jot them down. If I just did that one, I'd say it was NaBr and I2. So come down here. One of those 6 pairs is NaBr and I2. So you're in charge of writing the other 5 down. Now the 3 pairs of chemicals that react, we're going to write them again. So NaBr and Cl2, NaI and Cl2, and NaI and Br2. Now we're going to circle the element that was replaced and put a box around the element that replaced it. So what happens is this single element right here, whoops, comes in and kicks that element out. That comes down and becomes Br2. And it is yellow in color. This element comes in, kicks out the iodine, that comes down and becomes I2. That's purple in color. And that same thing happened up here. All right, so we're going to put an element around the element, or excuse me, a circle around the element that was replaced. So I put a circle around the bromine, that got replaced. You put a circle around the iodine because it was replaced, and you put a circle around the iodine here also. Then put a box around the replacer. Not that kind of box. Okay, so box, box. I deleted my circle, and a box. All right, now the atoms in the boxes, are they bigger or smaller than what they replaced? So we're going to compare chlorine to bromine. So if we want to do that, we whip over our periodic table. Here's chlorine, here's bromine. Chlorine, bromine. So which is bigger? Bromine's bigger. Chlorine is smaller because the atoms get smaller as you move to the right and also as you move up. Let me get back to my document here. There we go. Okay, so the atoms in the boxes, remember chlorine was higher on that table than bromine was, so chlorine is smaller. And when the atoms in the boxes were alone meaning like Cl2 and so on. So let's take a look at chlorine. So that's Cl2 right here. And its charge is 0. But when it reacted, the product of this reaction I didn't write down is actually NaCl. And in NaCl, the chlorine has a -1 charge. So it became negative. So what happens when you gain electrons? You become negative. So they must have gained electrons. All right, now do small atoms or big atoms gain electrons more easily? Well, last week we talked about electronegativity and the tendency of smaller atoms to gain electrons more easily. So small atoms gain easier. That's why they're small, because they're pulling in electrons. So looking at our data, what's the most active halogen? If you come up here, did anything replace the fluorine? So you had NaF, and it was this clear green color, that'd be chlorine, right? So chlorine didn't kick out the F. Did bromine kick out the F? Nope. Did iodine kick out the F? Whoops. Did iodine kick out the F? No. That's I2. So what's the most active? It'd have to be the F, because nothing was capable of replacing it. So nothing's capable of replacing the F, therefore it's the most active. All right, that's the lab. I didn't quite go through everything, but I did most everything. You just got to finish up number 2 here. All right. Hope that helped, and I'll post it, and that's the end of the lab review.